Introduction to Programming. Learning Objectives. In this chapter, the user would learn the following in detail: the basic model of computation, algorithms, flowcharts, programming languages, compilation, linking and loading, testing and debugging, documentation. The basic computational model. Introduction. Problem definition. A problem definition involves the clear identification of the problem in terms of available input parameters and desired solution. Approach towards solving the problem. After a problem is identified, the user needs to implement a step-by-step solution in terms of algorithms. Graphical representation of problem-solving sequence. This steps involves representing the steps of algorithm pictorially by using a flowchart. Each component of the flowchart presents a definite process to solve the problem. Converting the sequence in a programming language. Converting the graphical sequence of processes into a language that the user and the computer can understand and use for problem solving is called programming. After the program is compiled, the user can obtain the desired solution for the problem by executing the machine language version of the program. Algorithm. A sequential solution of any program that is written in human language is called algorithm. Algorithm is first step of the solution process. After the analysis of problem, programmer writes the algorithm of that problem. Sample algorithm. Algorithm to reverse the digits of an integer. Input. Number to be reversed greater than equal to n. Output. Reversed number n. Step 1. Input the number to be reversed n. Step 2. Assign the value of the number n to m. Assign the value L equals 0. Store the remainder which obtained by getting the modules of n and 10 in a variable k. Step 3. Divide m by 10. Assign L equal to product of L and 10 and add the sum to k. Step 4. If m is greater than 0. Yes. Repeat step 3. No. Output. The reverse of the number n is L. Step 5. Stop. An algorithm is a step-by-step procedure for solving a stated problem using a reasonable amount of time and storage. Every problem has some input information and some desired results to be obtained. The important aspect is to determine if the information available is really sufficient to solve the problem at hand, and if it is so, what are the procedures that should be applied to the given information or data so that the required result can be obtained. The development of a proper procedure to solve the problem is called an algorithm. The operations that can be included in an algorithm are constrained by the possibility of a computer carrying them out. Each operation must be unambiguous about the process to solve the problem. The steps in the process must be effective enough to be theoretically done in a finite amount of time and memory. An algorithm terminates in a reasonably short time. Sample algorithm. Go to bus stop. Catch bus number M7B. Purchase a ticket. Get down at the market bus stop. Example of algorithm. Find out if number is odd or even. Step 1. Start. Step 2. Input number. Step 3. Remainder equals number mod 2. Step 4. If remainder equals 0, then print number even. Else print number odd. End if. Step 5. Stop. What is pseudocode? Pseudocode is a simple way of writing programming code in English. Pseudocode is not an actual programming language. Pseudocode should not include keywords in any specific computer language. It should be written as a list of consecutive phrases. The user should not use flowcharting symbols, but he can draw arrows to show looping processes. Indentation can also be used in pseudocode to show the logic. The purpose of using pseudocode is that it is easier for humans to understand than conventional programming language code, and that is a compact and language-independent description of the key principles of an algorithm. Pseudocode is used to quickly draw the outline of a program. It can use any human language. Example of a pseudocode: initiate the program. Loop until I equals 10. Write "Hello World" to the screen. End, exit the loop. This is a pseudocode. It would not work if you ran it through a C compiler, but it explains the structure of the code and how users are planning to implement it. Example of pseudocode: if student's grade is greater than or equal to 60, print passed, else print failed. End if. Flowchart. What is a flowchart? A flowchart is a pictorial representation of the steps that are involved in the procedure. A flowchart also shows the logical sequence in which the steps are to be performed. A flowchart consists of boxes called the symbols and arrows called the flow lines. The box depicts the process and the flow line indicates the next step to be performed. Terminal box. This symbol is used to indicate the beginning or the end of a flowchart. When this symbol is used for start, no flow lines can enter it. Only one flow line can leave this box. When the terminal box is used for stop, no flow lines can leave this box and any number of flow lines can enter this box. There can be only one start symbol in each flowchart. However, there can be more than one stop symbol in a flowchart. Input or output box. The input or output box is represented by a parallelogram. This symbol indicates any function of an input or output device such as keyboard or printer. An input or output box makes data available for processing or displays the result of processing on the screen. Process box. The shape of the processing box is a rectangle. This symbol represents one or more instructions that perform a processing function in a program. Examples of processing functions are addition, subtraction, multiplication, division, or moving data to storage or assigning a value. Decision box. The shape of a decision box is a rhombus. This box is used when two quantities need to be compared. The decision box is also used for a testing condition. Decision box results in two alternative answers to the condition: true or false. The equality less than or equal to, greater than or equal to, and not equal to operators can be used in the decision box. Example of algorithm and flowchart for the same problems. Algorithm for calculating factorial value of a number. Step 1. Start. Step 2. Read the number n. Step 3. Initialize. I equals 1, fact equals 1. Step 4. Repeat step 4 through 6 until I lesser than equal to n. Step 5. I equals I plus 1. Step 6. Fact equals fact multiplied by I. Step 7. Print fact. Step 8. Stop. Process finish of calculating the factorial value of a number. Programming language. Introduction. A programming language is a set of symbols, grammars, and rules with the help of which one is able to translate algorithms to programs that will be executed by the computer. The programmer communicates with the machine using programming languages. There are many different classifications of programming languages, and these programming languages differ in their closeness to the machine and in the way they are structured. Most of the programs have a highly structured set of rules. The primary classifications of programming languages are machine languages, assembly languages, high-level languages. Machine-level language. Machine language is a collection of binary digits or bits that the computer reads and interprets. Machine language is the only language a computer is capable of understanding. Machine-level language is a language that supports the machine side of the programming or does not provide human side of the programming. It consists of binary zeros and ones. A machine-level language is the lowest form of computer language. Each instruction in a program is represented by a numeric code, and numerical addresses are used throughout the program to refer to memory locations in the computer's memory. All bookkeeping aspects of the program are the sole responsibility of the machine language programmer. Finally, all diagnostics and programming aids must be supplied by the programmer. Also included as machine-level programs are programs written in microcode, that is, microprograms. Microcode allows for the expression of some of the more powerful machine-level instructions in terms of a set of basic machine instructions. Each computer has only one programming language which does not need a translating program, the machine language. Machine language programs, the first-generation programs, are written at the most basic level of computer operation. Because their instructions are directed at this basic level of operation, machine language and assembler language are collectively called low-level language. In machine language, instructions are coded as a series of ones and zeros. The machine language programs are cumbersome and difficult to write. The machine language is native to that machine and understood directly by the machine. The machine language generally has two parts: opcode, operand. The opcode of machine language tells what function to perform to the computer. The operand gives the data on which the operation has to be performed or the location where the data can be found. Advantages: machine-level instructions are directly executable. Machine-level language makes most efficient use of computer system resources like storage and register. Machine language instruction can be used to manipulate individual bits. As the machine inherently understands machine instruction, machine languages are very fast. Disadvantages: difficult to program. Programming in machine language is the most difficult kind of programming. Instruction should be encoded as a sequence of incomprehensible zeros and ones, which is very difficult. Error-prone. In machine language, the programmer has to look into all the activities like memory management, instruction cycle, etc., which diverts his attention from the actual logic of the program. This frequency leads to error. Machine dependent. Every computer is different from one another in its architecture. Hence, instructions of one machine will be different from the other. As machine-level language are device-dependent, the programs are not portable from one computer to another. Programming in machine language usually results in poor programmer productivity. Programs in machine language are more error-prone and difficult to debug. Computer storage location must be addressed directly, not symbolically. Machine language requires a high level of programming skill, which increases programmer training costs. Assembly-level language. A set of instructions for an assembly language is essentially one-to-one with those of machine language. Like machine language, assembly language is unique to a computer. The big difference is that instead of a cumbersome series of ones and zeros, assembly languages use easily recognizable symbols called mnemonics to represent instructions. As said before, machine language and assembly language are low-level languages and are dependent on particular machine architecture. They are more close to the machine rather than the programmer. The only difference between the assembly language and machine language is that assembly language is relatively easier to use than machine language. In a pure assembly language, each statement produces exactly one machine instruction, one-to-one correspondence between machine instructions and statements in assembly language. So, an online assembly language will produce an N-word machine language program. Assembly language which uses mnemonic codes is easier than machine language using binary or hexadecimal codes. It is easier to remember ADD, SUB, MUL or DIV than their corresponding numerical values in machine language. Assembly language uses symbolic names for memory locations, while machine language needs numerical values. The assembly language can directly test if there is an overflow bit, while a higher level language cannot. An assembly language can only run on one family of machines. Each machine has its own assembly language, while a higher level language can run on many machines. Advantages: assembly language is easier to use than machine language. An assembler is useful for detecting programming errors. Programmers do not have the absolute address of data items. Assembly language encourage modular programming. Disadvantages: assembly language programs are not directly executable. Assembly language are machine dependent and therefore not portable from one machine to another. Programming in assembly language requires a higher level of programming skill. High-level language. High-level language is a language that supports the human and the application side of programming. Typical features: ability to logic structuring of the algorithm, cross-platform independence. A language is a machine-independent way to specify the sequence of operations necessary to accomplish a task. A language can be designed to be expressed in a concise way, a common sequence of operations. A line in a high-level language can execute powerful operations and correspond to tens or hundreds of instructions at the machine level. Although many programmers prefer assembly language because it works more efficiently, the power and flexibility of the new generation languages have put them beyond low-level languages in terms of both human and computer efficiency. Consequently, more programming is now done in high-level languages. Examples of high-level languages are BASIC, VB, C, C++, Java, Perl, etc. High-level languages are more like English statements which are easy to understand and to use. High-level languages are more close to the programmer and ease the task of programming. High-level languages provide a richer set of instructions and support, making the programmer's life even easier. Yet, before a high-level program can be executed on a given CPU, it must be translated back to the machine code. A programming language such as C, Fortran or Pascal that enables a programmer to write programs that is more or less independent of a particular type of computer. Such languages are considered high-level because they are closer to human languages and further from machine languages. In contrast, assembly languages are considered low-level because they are very close to machine languages. Features of high-level languages. High-level languages are easily understandable. The programs that are developed in high-level language are portable. In case of high-level languages, debugging of the code is easy and the program written is not machine-dependent. Advantages of high-level languages include easier to program. The programmer can concentrate on the logic of the program rather than on the register, ports, and memory storage. Machine-independent. Provided some other machine has the same compiler and libraries, the program can be ported across various platforms. Easy maintenance. A program in a high-level language is easier to maintain than assembly language because it is easier to code and locate bugs in high-level languages. Easy to learn. The learning curve for high-level languages is relatively smooth than low-level languages. Other than this, high-level languages are more flexible and can be easily documented. Compilation. The compiler program translates the instructions of a high-level language into a machine-level language. A separate compiler is required for every high-level language. High-level language is simply a programmer's convenience and cannot be executed in their source. The actual high-level program is called a source program. It is compiled, translated to machine-level language program called object program for that machine by the compiler. Such compilers are called self-resident compilers. Compiler compiles the full program and reports the error at the end. What is compilation? The compiler is the tool to convert a program written in a high-level language into the sequence of machine instructions required by a specific computer to accomplish the task. Users typically control details of the operation of compilers by means of options supplied on the command line or directives embedded in the program source, but they seldom need to examine the resulting machine language code. This process of converting high-level language to machine level is called compilation. The translation of source code into object code by a compiler. Compilation process. The compilation and execution process of C can be divided into multiple steps. Pre-processing. Using a preprocessor program to convert C source code in expanded source code. Hash include and hash define statements will be processed and replaced with actual source codes in this step. Compilation. Using a compiler program to convert C expanded source to assembly source code. Assembly. Using an assembler program to convert assembly source code to object code. Linking. Using a linker program to convert object code to executable code. Multiple units of object codes are linked together in this step. Loading. Using a loader program to load the executable code into CPU for execution. Linking and loading. What is linking? After all of the files are compiled, they must be merged together to produce a single executable file that the user use to run the program. In C, most compiled programs produce results only with the help of some standard programs called as library files that reside in the computer. This process is called linking. The result obtained after linking is called the executable file. To build an executable file, the linker collects and libraries. The linker's primary function is to bind symbolic names to memory addresses. To do this, it first scans the files and concatenates the related file section to form one large file. Then, it makes a second pass on the resulting file to bind symbol names to real memory addresses. Linking is the process of taking some smaller executable and joining them together as a single large executable. Loading the executable into memory prior to execution. There are two types of linking: static linking, dynamic linking. Static linking occurs at compilation time, hence it occurs prior to loading a program. With static linking, the external symbols that are used by the program, example function names, are resolved at compile time. Dynamic linking occurs at runtime, so it occurs after or at the time of the loading of a program. With dynamic linking, the symbols are resolved either at loading time or at runtime when the symbol is accessed. Lazy binding. What is loading? After the files are compiled and linked, the executable file is loaded in the computer's memory for executing by the loader. This process is called loading. Program loading is basically copying a program from secondary storage into main memory so it's ready to run. In some cases, loading is just not copying the data from the disk to the memory, but also setting, protecting bits, or arranging for virtual memory map, virtual addresses to disk pages. Testing and debugging. Introduction. Testing involves finding problems in the code. What does one test for? Compilation errors. Syntax errors. The compiler cannot understand user's program because it does not follow the syntax. Common syntax errors are missing or misplaced brace, missing return type for a procedure, missing or duplicate variable declarations. Type errors. These errors include type mismatch when the user assigns a value to a variable and type mismatch between actual and formal parameters. Runtime errors. Output errors. These errors result when the program runs but produces an incorrect result. An output error indicates an error in the meaning or logic of the program. Exceptions. These errors occur when the program terminates abnormally. Examples include division by zero and out of memory. Exceptions indicate an error in the semantics or the logic of a program. Non-termination errors. These errors occur when the program does not terminate as expected but continues running endlessly. Debugging consists of isolating and fixing the problems. Testing and debugging are necessary stages in the development cycle, and they are best incorporated early in the cycle. Thoroughly testing and debugging individual components makes testing and debugging integrated applications much easier. Documentation. What is documentation? Documentation of a program consists of written description of program's specification, its design, coding, operating procedures, etc. Documentation is either incomplete or inaccurate, making the user and maintenance programmers irritated and annoyed over it. Documentation can be broadly classified into two types: documentation for users, documentation for maintenance programs. The return text and comments that make a program easier for others to understand, use, and modify. The compiler in the compilation process ignores comments. It provides information about the steps and procedures. Conclusion. In this chapter, we have covered the following aspects of Introduction to Programming: the basic model of computation, algorithms, flowcharts, programming languages, compilation, linking and loading, testing and debugging, documentation.